Welcome to Digital Ship VPO webinar. Today we have the opportunity to learn about the case study on integrating vessel loading computer with vessel performance management that CPO Containerschiffreederei and Navis has tried and actually succeeded. I welcome our guest speakers, Bastian Gehnke, Senior Product Manager with Navis, and Hannah Ohorn, Head of Technical Development at CPO Containerschiffreederei. Navis is sponsoring this webinar. Use the opportunity to ask lots of questions that we'll get into after the talks. And as always, we will begin with Carl Jeffrey, founding editor of Digital Ship, giving us some background into today's story. Let's go.
Okay, so we've got a different take on vessel performance today, and that's because the first speaker comes from what might be the largest maritime software company in the world, if you include the container terminals as part of Maritime. So Navis makes software for 460 container terminals in 80 countries. That includes some of the biggest ones, and it also makes software for container terminal automation. So sticking with containers, it also makes software for the loading computers on ships, which are for planning where the containers sit, and that's used by 65% of container shipping lines. And it also has 25% of the market for stowage planning, including 34 shipping companies. Navis is based in San Francisco. So as a well-funded software company, so it's going to look at software from a different way to a startup. So it's got the budget to tackle really difficult problems, which we keep hearing about. So that's data integration is a really difficult problem, avoiding rework, avoiding manual processes, making APIs which work well and connect to other systems, getting data in the right format. So this is perhaps what's possible when you have a good software company behind you. And so we're moving from the vessel loading computers into vessel performance. It also makes products for vessel performance. So that's a broad picture. So that's fuel consumption, but also issues like making sure that the containers don't have a risk of falling off the vessel. Our first speaker is Bastian Gehnke, who's a senior product manager with Navis. He's based in Flensburg, which is 100 miles north of Hamburg. And our second speaker is Hannah Ohorn, who's the head of technical development with CPO Containerschiffreederei in Hamburg. They're part of the Ohorn group. Hannah's formerly performance manager fleet optimization with AP Müller Maersk in Hamburg and a technical superintendent with Columbus Ship Management. CPO Containerschiffreederei has got 42 container ships, so between 4,000 and 14,000 TEU. So first of all, we're going to have a talk from Bastian. So he's going to talk about new ways to help shipping companies manage performance and reduce fuel consumption, minimizing data processes and better decision making. And then Hannah's going to talk for 15 minutes about her project, which is integrating the loading computer with a vessel performance system, which is something we've never heard about before. So you get a single source of truth, balancing the shipboard computer with the office networks. We should have plenty of time for questions, so please load them up in the Q&A box at the bottom of the screen. And I'd like to invite Bastian to give his talk. Thank you.
Thank you very much, Carl, for a nice introduction. I will share my screen, and I would like to talk with you about the maximizing of fleet performance with sustainable operations today. So first of all, thanks also for the company introduction. I will give a little overview of what's the Navis next generation of the ecosystem. Navis originally, as introduced, has been on the terminal solution side and doing software for hundreds of terminals today, looking into areas of automation, planning, execution, as well as on dock and rail. While we are talking today about a business unit, carrier and vessel solutions, where we are looking at products in the area of storage planning, loading conditions, as well as fleet performance. Fleet performance will be the topic of today. The third area inside Navis is the inland solutions, which is pretty new, powered by BRE Rail, where we're looking into intermodal trucks and shipper visibility. So today we are focusing on our stream carrier and vessel solutions. On today's agenda, I would like to talk a bit about the transformation of the maritime industry and a few administrative difficulties which we have identified. I will come through best practices on maximizing fleet performance with sustainable operations, and then explain a little bit the Navis solution, which is the BlueTracker Suite and its benefits. At that point, I will hand over to Hannah from CPO, talking about Navis solutions and benefits use cases, how they made the experience with our solution, followed by an extensive Q&A. Let me start talk about the transformation of the maritime industry and the administrative difficulties which we have identified. So we all know that the maritime industry evolves over time quite rapidly, starting in the 70s, introducing MARPOL and those codes. The latest in 2018, the European Union has introduced MRV regulation. On top of that, a year later, the IIMO came up with the data collection system, IMO DCS. And just in 2020, we have been facing the major challenge to address the sulfur cap 2020. Very ambitious goals has been set for the industry to reduce carbon emissions. Along with that, financial institutions are coming up, derived from Poseidon principles. New KPIs have been introduced to look into the annual efficiency rate of vessels to meet some climate-bound foundings. From 2023, we will face additional things which are also being announced by the IMO when it comes to CII and EEXI, which are performance indicators, again, looking on the emissions of a vessel. So all these additional regulations, which are coming up in the last years, are putting additional pressure on the ship owners and ship managers, which are already in a quite busy business today. On top of the regulatory challenges, we have lots of administrative difficulties which we identify. Those are not only on the maritime industry specific, these are general administrative difficulties, but we face them especially also in the maritime industry. The first one are manually intensive processes. So I think we all know the problem of siloed IT solutions, hundreds of Excel sheets, copying data from A to B, which are very time consuming and just at the end of the day to meet a certain format, which we have to submit to another stakeholder. But as long as we're talking about the same data, the manual processes are pretty intensive but unnecessary. The second challenge is the limited availability of data and KPI integrations. So if we look at it from a vessel's perspective, we basically have only the one vessel which is generating data. But the different stakeholders, marine ship owners, managers, and charterers are looking at the same information in different systems. Thus, the KPIs are not being integrated and the data availability is limited. This generates different results on the same things we're actually looking at. The third thing, very important, is the lack of communication. The crew on board of the vessel is being pretty much isolated and disconnected from the shoreside teams and therefore from the shoreside analysis and systems. I can remember from my time at board that it was very difficult to make phone calls via satellite communication. It was nearly impossible. Every email required the permission of the captain, stuff like that. Technology has changed. Vessels are better connected today, but the reality shows that the crew is basically still pretty disconnected. This all leads to increase of cost and decrease of efficiency as well as sustainability. Let's have a look on what could be the best practices on maximizing fleet performance with sustainable operations, addressing the just mentioned challenges. We have looked at it from a holistic approach, a pretty high-level overview, starting on the upper left with elimination of manual processes. Replacing manual recurring processes with IT solutions is one of the major advantages by bringing into software. Automating data validation and aggregation on the shore side basically can replace manual processes and can save up to 80% of time by simply automating recurrent tasks. In example, complying with the regulatory bodies and creating the exports which are required in the right format on the button click. On the other hand, finding the single source of truth. Instead of copying data from A to B and creating redundancies, we should basically identify the single source of truth of the data and make use of it at certain systems. So systems which are connected to each other and we establish API connections, we can basically make sure that we're looking at the same data in the different systems and we distribute the same information to the different stakeholders. Already mentioned, the loading computer is one of the things here, which we have brought into the network, and we are getting information about the stability and lash calculations on board of the vessel directly in the shoreside systems from the loading computer on board. So there's no need to copy paste data from the loading computer into any other reporting system, as we can connect the loading computer into the network and can get the information into the other systems as well. The third area is the crew involvement. So if you involve the crew, then you can really boost your performance because the crew on board is at the end of the day the one who have to take the corrective actions. As mentioned, technology has changed, so the crew can be better involved today based on the technology. But we have realized in the past that IT systems are often not really intuitive to use for the crew on board. You have to take into account that the crew on board does not have any IT or software skills. These are nautical and technical officers. To really involve the crew, smart solutions are required, which makes it easy for them to interact with the shoreside team and to really understand where the issues are and where they can improve. Without the involvement of the crew, we think that all software solutions and KPIs are basically pointless because they have to do the corrective actions at the end of the day. Let me give a little insight of the Navis solution, the BlueTracker Suite and benefits. I will do that on a very high level, as Hannah will later on go through some specific use cases and can explain that far better than me based on the experience with the system. The BlueTracker architecture is drawn here. So you can basically see on the blue side is the data collection stream, which is coming from onboard the vessel to the shoreside system. And the green area is the data analysis system, which feeds back the results to the crew on board. So on board the vessels, two important data collections are being made. On the one hand, using BlueTracker reporting, the manual reports can be filled out and sent to the shoreside system. On the other hand, sensor-driven data can be connected directly from the measurement on board and being fed into the analysis system as well. On the shoreside, BlueTracker One, which is a cloud-based analysis platform, enriches the data with additional data sources. Weather provider information, AIS data, or any other third-party systems can be connected to the platform as well. There's also a possibility to integrate data from in-house systems, in example, historical reporting data, which you may have collected before you have used BlueTracker reporting. Every analyzed KPIs and results of the analysis system can also be fed back into the in-house system or any other third party. So here we are establishing the API connections and make sure that the single source of truth of the different data sets will be made available. As we said, crew involvement is the most important. So BlueTracker One has a direct link back on board, and on board the feedback of the KPIs and the plausibility results and all the things being analyzed in the shoreside platform will be integrated again. Let's have a little closer look into the single solutions. On the one hand, BlueTracker reporting, which is a smart onboard reporting tool. It allows you to simultaneously edit the reports from several workstations. Only one installation is required using network capabilities on board locally without internet connection. You have the possibility to edit the reports at the same time. On the screenshot, you can see how two crew members are editing at the same time. Only the cell which is currently being entered is highlighted and blocked. The rest of the cells can be still entered by other users from other machines. There's a chat tool available so that the crew can interact with each other regards to any discussions by filling out the report or just asking what's next for lunch. The whole template, which data have to be filled in, can be customized on the shore side. The customers has the possibility and flexibility to rearrange the fields, hide what they don't need, and add their own data so that we can make sure this is the single source of reported data on board and it fits all use cases of the customers. The solution is mobile ready, so it works on mobile devices as well. In case you have tablets or smartphones on board available, connect them to the wireless network and report the data directly from where you read it instead of copying it to the computer. BlueTracker One on the shore side, as I said, will receive the data aggregated with the other data sources. An example, aggregating the measured data to the same time frames as the reported data to have comparable results. Based on that, there's a module-based concept which addresses mainly analyzing and reduction of fuel consumption and thus emissions, as well as the automatic generation of compliance reports, which can be done by the system automatically. Combining the several data sources allow you to create reports regards to AER, charter party compliance, and create a vessel ranking. This is just a high-level overview, and Hannah later on will highlight a few of these as a use case example. Let me sum up the 4 key areas which we are addressing with the BlueTracker Suite. On the one hand, as mentioned, automation can save you up to 80% of manual processes by simply automating them. The whole thing addresses efficiency. We are analyzing fleet-wide data and identify efficiency gaps of the vessel in order to reduce fuel consumption. You can improve the efficiency significantly by using the applications. And this is directly related to sustainability. Reduction of fuel also reduces emissions, and this contributes to the maritime industry into a greener future. The performance boost, last but not least, that's how we call empowerment of the crew to really do corrective actions on board and to convert the data into actionable items, which can then be executed. With that summary, I would like to hand over to Hannah and explain a little bit the benefits and use cases from a customer perspective, CPO.
Yeah, thank you, Bastian. I would like to take you now on a short journey in regards how we are dealing with optimizing our fleet at CPO. Bastian, if you would just turn to the next slide, please. Thanks. So actually, we are vessel owner and we are vessel manager, and we are taking our responsibility in regards to sustainable operations very serious, and therefore we are continuously aiming to increase our service efficiency and the benefits for our customers. Therefore, actually, we set up a future-oriented and, let's say, quite ambitious roadmap to reduce the vessel CO2 emissions. So, and in our opinion, let's say our vision is that vessels operation and subsequently the collected data is a key aspect to reduce the fuel oil consumption and to achieve the most for our environment. Therefore, actually, we were thinking about what actually do we need to reach our goal to make our vision working. So first of all, we defined that the increase of the data quality is the major step on our decent roadmap to get our vision done. Secondly, we had the interconnected data. We are using quite, and I will come to that on the next slide. We are having quite a lot of different data sources which we wanted to have in one single solution. So in one software, giving all different stakeholders the option to evaluate their individual requirement data for their own use cases. So actually, that's what the second thing is for us to reach our vision. Then, as I said already, Bastian, no, I'm not through. Thank you. So the next thing is that we wanted to have some kind of easy to use user interface. As I mentioned already, we want to have a management software, and this means that we don't want to have only the experts working with the software. We are having also so many different stakeholders which should be able to use the software in a decent way. Further on, we need to have some kind of futuristic smart solutions for all the forthcoming regulations and rules coming up in the future. And one also big thing is that we want to have data transparency. We want to have one single source of truth. Next, please. So here, as I mentioned already, I'm showing you what actually in our specific point we were struggling with to fit all the data sources we have in one system. So we had historical data from already 2 different manual reporting systems, which had to be integrated into the BlueTracker Suite. Then also we are having a lot of high frequency data. So let's call it automatic data, which is collected in 50-minute steps, or let's say in 1-minute steps, but then sent to shore. We have this from the nautical side, we have it from the engine department, and we have also high frequency fuel consumption data. Then we have the reporting data, the actual ones, which is done also by the reporting tool from Navis. We are having weather data, historical weather data, which has to be integrated. And the major point also today is adding the loading computer data into the system. Then I would like just to say, give you some kind of some insights how we are actually using the system and where do we see the biggest benefit. You see here, I want to share a screenshot with you what actually is our first step into developing, or let's say checking the performance of the vessel. You can see here the way that KPIs are immediately displayed. And one of the KPIs we are very much focusing on, as I said, this is the first step to reach our goal, is the data quality. And here you have a KPI which is set up directly to judge if everything is okay, if we can rely on the data, if we can work with it. If we can work with it and everything is fine, it's shown green. if something is going wrong, it's turning to yellow or even to red. So we immediately know, or the experts immediately know what to do with it. So we can drill down and check further on what's going on. What actually is the business impact for us? We experience, and that's really something I want to mention and want to point out, we experienced that we were reducing our labor hours to comply with environmental regulations by 90%. So that means MRV, IIMO DCS reporting was just done by, let's say, not only one click, but maybe less than 1 week work for the colleagues, because we had already some decent data and we checked the quality and the reliability already before. This is also pretty well for our further works, what we are doing in regards of energy efficiency and performance of the vessels. So actually we can really work with the data. We know the data is reliable. We do not have to question all the time what we are looking at. So our efficiency team is able to focus on improving the performance right away. So we are actually performing now a more proactive than a reactive approach in increasing the efficiency and also increasing the customer satisfaction. So I will just go now through some use cases. We are actually, I just want to display you some kind of generic view on how we are doing it. So I prepared 3 different use cases. As Bastian mentioned already, we will just go, and the first one will be the charter monitor. So why I have chosen this use case as the first one, because here we can see immediately, and this is it's an application within the system where we just only had to set up the baselines, and then everything, let's say, more or less will be done by the system. So to check, and on one click, we can check how our vessel is performing in regards of the charter party, for example, or the fuel efficiency. It depends on how we are setting up the baseline, how it should be compared to. So we can immediately identify the carbon intensity and see if everything is fine or if it's not fine. If it's not fine, we can always drill down to a more, let's say, holistic view on what's going on and what the issues are where we have to point out to. The next use case is something with the high frequency data. It's always like, yes, we are gathering a lot of data, and actually what we are doing with it, we are not only monitoring how the main engine is performing, we are also monitoring how the auxiliary engines, for example, performing. We have container vessels with a high reefer capacity, so actually also our auxiliary engines are consuming a lot of fuel, and which leads to a high carbon intensity. So what actually do we see here? I just chose this picture because I think it's quite clear, or let's say it's making the picture quite clear. We are having here our auxiliary engines displayed in a high frequency data, and we are focusing here on how the generators are handled, or let's say how the crew is handling the generators. Mostly, let's say we see some kind of subjective, let's say, approach on handling the safety issues in regard of double running of auxiliary engines. Just to mention, our auxiliary engines are actually performing in the best way in around 80 to 85% load. So of course, it makes much more sense to have one engine running on 70, on 75, 80% load, more than to have 2 generators running on 40% load. So actually here we can see right away, and also on, let's say, more or less real time, what's going on, and we are having the options to react immediately and not retroactive. The next use case actually is the one which might make it a little bit more unique. And this is the integrating vessel's loading computer with our vessel performance management. So actually why we went this way, to integrate also our MAX3 loading computer to the system. To make the picture complete on what's going on, and also how the performance of our vessel is that we need to have all informations on hand to make the picture complete. So actually having also this loading computer informations on hand, we can go for how is the trim situation, what is the tank status, how is the ballast water system handled. So in regards of connecting this kind of data together with the data we have gathered already for the high frequency approach, or also for the manual reported data, we are getting the complete picture, which make it really, really unique. So this is also, it's as I said already before, it's not only that our energy performance team is using the system, it's also used by the technical superintendents, it's used by the nautical superintendents, it's also used by our QHSE department and also to our safety and security. So in regards of increasing the safety on our vessels, having a full visibility also on the DG, all loading situations, all data from all containers we have on board makes it quite intense and fast to react if something happens on board. Just give me on the next slide some kind of overview how it looks like. And the first, or let's say the picture in the background, you see a complete MAX3 connected condition viewer. This is only one page which we are showing there, but this is giving the complete overview of what's also visible on board. So we are having some kind of loading summary, we have strengths, we have all the tank situations, and we have, as I said already, a complete cargo list, and we have also a condition check view where we see if something is with the lush force is not okay or whatsoever. So, and these data is now also integrated in our BlueTracker 1. So in the picture before, so in the front, you can see that the data is also always evaluated against the data which is sent by the vessel's crew. So we have a complete picture of what we really have from the system and also from the reported data. And this is the best way to evaluate the complete situation on board. So the future vision, I guess I will start with the vision actually we have, and then it might be on Bastian's and to add some of them, their visions. What we are actually looking for is if we have so many different data sources and so many data also available in a high frequency way, why not also pre-filling the reports, or let's say the manual reporting, reducing the workload from the vessel's crew by having them pre-filled and let's say make the lives on board easier. One thing, as I said, this was also on my first slide, that data transparency is something we are really aiming for. This means that we would like to be able to share the data across different stakeholders, gaining more transparency in regards of maybe also sharing the data with our customers. For example, we are all gathering the same data. Why will not also be able to share it in a decent way? We are also looking for is that we want to have a clearer picture of what's getting in regards of fuel on the vessel and what we are actually taking out by burning them within our engines is some kind of decent bunker management tool we are looking for. Minimizing manual reporting efforts for the crew, I just mentioned. So this is something free from CPO I actually aiming for.
Yeah, thanks. And let me hook in at that point, Hannah, to pick just two of your examples where actually we have a shared vision as well, and how we are looking to address these points. The first thing is the minimizing of manual efforts for the onboard crew. I have been a sailor at sea as well. It's one of my hard key topics, I would say, to address these and to keep the crew efforts minimized. I think with today's solutions and available technology on measuring data on board, lots of things can already be automated and potentially being replaced from reporting, but still there's always a need to add a few contextual information via reports. Things like a bunker analysis and stuff are usually being reported manual today, and I think these are important information to add to the system to have the holistic overview. However, we also see a step-by-step thing. So can't we reduce the effort of manual reporting somehow just by replacing what's anyhow measured, connecting to the loading computer, and do not let the data being copied into the reporting system. So things like that, bringing us down the road, I would say, to a maybe not full replacement in the first step, but at least a significant reduction in manual effort. On the other hand, I understand there are several stakeholders, and this addresses also your point of data sharing. If the charterer of the vessel requires also manual reports to be received from the crew on board, and they may have some additional values to be filled, additional data they would like to get from the crew, we could realize this in the same tool. So there's just a second template for the charterer, which will pop up for the crew, and only the different data or the additional data have to be filled out, and then the full report can be submitted to the charter as a second stakeholder. So also here, let's reduce the effort for the crew. Let's collect only once what's have to be created only once, and let's share this across with the other stakeholders. I think these are two of these things. And let me add one more point to come a little bit more from only checking what has been happening in the past. We also would like to look into prediction using machine learning and other predictive analysis to identify root causes of performance issues which have been already happened in the past, learn from the data, and try to give some predictions or early alerts before it happens again on other vessels or in other situations. Yeah, I think this is also our side of the future vision going ahead with the solutions, and I think this will bring us hopefully where we want to head to. From here, let me open up the last slide for the Q&A. So if you are interested in automating your EUMAV and IIMO DCS compliance, this is something what we're currently offering for free. Just sign up for a trial and contact us for that. And I think with that slide, we may go into the Q&A, Carl.
Oh, thank you very much. And what I really loved about your talk was how you talked about making things easier for seafarers. I think that's something we often miss these days. I was on a International Chamber of Shipping webinar yesterday, and they were talking about updating the training requirements for seafarers to use new digital technologies. And I spent the whole webinar thinking, surely this software should be easy enough to use that people don't need to be trained. But we also got some great questions on the Q&A. So maybe two that got my attention. So Celia Welder on her LinkedIn page is a principal engineer ship technology at Equinor in Stavanger. So she's asking about combining trim curves with the loading computer in conjunction with the Voyage data. I think she put that question up before you started talking about integrating the loading computer with the fuel performance, but I don't know if there's anything else you'd like to add there. So maybe that's well for Hannah. And then she's also asking, are Navis going to take this solution into the tanker segment? So that's maybe that for Bastian. So should we start with Cecilia's question first, do you think?
Yeah. Should I say something to that first, Hannah?
Yes, if you like.
Yeah, if you like.
Yeah, so basically it's a very good point, and this is one of the reasons why we see us in a very good position integrating the loading computer. So we at Navis have a quite good market share with the loading computer, and the container segments is more than 65%. Thus, we have quite good experience on what the loading computer is capable to do. And one of the key things is indeed the trim optimization module, which is also being connected to the shore side. And one major thing to take into account is that you have always the theoretical optimal trim, which you can reach or should reach just from the theoretical model behind, which tells you, hey, this is the point in your current operational situation where you would consume less. However, you cannot, with each and every condition on board of the vessel in terms of the loading condition, you cannot reach this because there are just simply physical constraints, physical limits which you cannot overcome based on the current cargo and ballast water situation. Taking these information into account from the loading computer will give you a real reachable trim optimal point. And this is currently a module which also lives inside the loading computer, and this also shall make the way into the performance solution. Hannah, anything to add from your side before I answer the tanker question? Maybe as you are Containerschiffreederei, I would say.
No, I think everything is mentioned. Otherwise, maybe the questioner might raise his hand again.
All right, then let me just give one sentence to the tanker solution. Yes, we are looking also on the tanker side. The loading computer also is available for tanker vessels, so we are not limited to that. And also the whole performance solution, of course, can address tanker vessels as well. So our performance and compliance modules, which are certified, are also certified for tanker as a vessel type. Today, we have some use cases around the containers, maybe highlighted a bit more as we have CPO here and as a customer. But in general, the tanker market is also very welcome to use our modules, yes.
Okay, so if we go to the top of the list, I've got time to look people up at the moment. Paolo Pupo is Digital Transformation Manager at ABB. So he's asking, this is what we were talking about before, connecting the onboard loading computer. Can you connect it to the vessel LAN? Is that for Hannah to answer, do you think?
Oh, yeah, I can answer that. Actually, it's pretty easy because no, we haven't connected to the LAN, let's say, yeah, or let's say more or less, we are just sending up, but maybe from the software development side, Bastian can answer this much better than me, but actually we are just pushing out the loading loading conditions to via mail, or let's say via a stable connection, and then we are pushing out. But I think, Bastian, you can say, because I think it is not that you are not allowed to connect it to the LAN. It's just something it's usually not done.
Yeah, that's exactly correct. So it's very common that the loading computer is not connected to the LAN directly, and this is also not necessary. So as I mentioned, we are the maker of the loading computer, luckily in CPO case of the entire fleet. So we are on the control of the loading computer, how to push the data out. And there are several options actually. So of course you can connect directly to the internet and push the data into the API on the button click, but there are other ways you can do. So we can store the data locally on board of the ship, and the email program can pick them up and send them to the shore side. Or in the simplest way, the crew can simply send an email and attach a specific export format of the loading computer. So the whole thing here, we have also addressed from the single source of truth perspective, looking from the loading computer side and not from the data collection system on board, trying to connect to the loading computer. So we let the loading computer itself transmit the data to the shore side, and we bring them together there with the performance solutions.
Or you've got a vessel, if you've got a vessel local area network, you can kind of export the file into the whatever you're sending email from. Is that?
Exactly, that's the simplest way to do. And if you want to automate that further, there are of course technical possibilities to do so.
Okay, so Martin Taylor is the chief executive of One Ocean Group. He's asking if the fuel data in the system complies with the IIMO requirements for electronic record books and logbooks, or is this something separate? Is that a?
That's really interesting question, Bastian.
Yeah, it is. Basically, this is a very good question. Currently, the reporting system is a reporting system and not electronic logbook. But as electronic logbooks are coming up more and more, we are of course looking into that. And there's also two possibilities we may have. On the one hand, data could be connected again. So electronic logbook could just make a connection to the reporting system. So data not necessarily need to be filled out twice. We fill them once in only one of the systems, and then we hand them over to the other system via a handshake, so to say. And on the other hand, of course, a reporting system could also evolve into having a module which is a approved electronic logbook. Currently, it's a decoupled systems, but the future shows, or the digital journey shows that digital logbooks are coming up more and more, and for sure those should be addressed as well, and there should also be double entry avoided.
Okay, there's a question from Ian Mackenzie, which I think is a bit out of scope, so I think we'll skip over that unless there's something.
I just read it.
I've noticed. I don't think there's something
quite interesting.
But Taras Pavliuk, so he's asking if you're providing the GSM and SATCOMs, or you're just giving the hardware and access. Bastian, is it? You're getting into SATCOM?
Yeah, something I can answer. When it comes to potentially the question is regards to the sensor measure data, I guess, because the reporting system, it's a manual entry of data, and as I said, it's very flexible to choose what data you want to enter, and then it's a simple API call which sends the data. But if it comes to measure data, the question is how it is transmitted. And what we do there is basically we connect to the existing satellite communication system of the vessel, and we utilize what's there. So the configuration is done during the project with either ourselves or with a partner, and then the data will be transmitted via the existing connection. So no additional GSM or satellite connections being established. We are utilizing the IT infrastructure on board of the ship.
Okay, so Anton Zakharov is from iGauge, which is a company making devices to collect from old equipment, putting it in a digital format. But he's asking what nautical data you're collecting. So I think that means sort of sensors on board the ship. You didn't say anything about that. I don't think you're getting into that, are you?
Actually, no, not in detail. I just said that we were collecting high frequent nautical data, and actually everything what we are collecting on the VDR, for example, we are taking from the actors, the positioning, we are taking also weather data, wind sensors, for example, and we are taking also the rudder rate of turn, and actually everything what you can imagine what we are having on the bridge equipment. So everything what is also necessary for the VDR, we are actually collecting and sending ashore.
Well, yeah, I've just noticed the other two questions are also about this. This theme comes up awful lot, a lot of the time. I think it must be something that companies have a lot of trouble with collecting data. And so Per Willa Moyes is asking, how do you collect data and how do you transfer it? Max Rech is asking, how much wrong data do you need to filter out? Mike Powell is asking about hull stress monitoring. I don't know if that's sensors Sounds like it might be. Do you want to?
Shall I say something to that? Actually, the one thing, how do you collect the data on board? One thing is we are collecting the manual reported data via the BTO, and the other thing is we're having another provider who is collecting the data for the automatic data, so the high frequency data. So it's a server structure where we are collecting, I think, depending on the interface and the connection, 1 minute steps data, and this then is stored on board the vessel and is sent every 15 minutes ashore. So, and how many wrong data do you need to filter? Actually, it depends on the use case, what actually means wrong data. So the system already has, in regards of the charter monitoring, for example, we have already defined what the situation, or the let's say the wind speed, current, and so on, how it should be set up, and then the system actually is filtering already before we are looking at, or let's say is filtering everything, all data sources, 8 data points out, which are actually not belonging to our description. So these kind of data points are then still shown, but they are just, let's say, shown in gray, so they are not taken into account to evaluate the use case actually we are looking at.
Maybe let me add one more thing here, because I think there's also quite a nice concept in place, which is already categorizing the data into certain categories. So if a data set comes in and we are identifying let's say we have a set of data which is representing a report, we're looking in where is the plausibility issue being identified. So if this is something in the auxiliary engine information, an example where we see, okay, there might be a false data set in terms of the auxiliary engines, we are identifying that this falls in the auxiliary engine performance area, and then when you filter out the data, it will be taken out for any auxiliary performance analysis, but still the data set can be used for high performance analysis, as auxiliary engines doesn't play a role in the high performance. So by giving the data some kind of categories and looking in where the data should be filtered out and where you may still use the data set, this gives you the possibility of use the maximum of data available, but making sure that you just work on the correct data foundation.
Oh, okay. So question from Richard Grad at the bottom. I think he's the Marine Operations Team Lead at Geest Line in Greater Southampton. He's asking if any loading computer software can be integrated into the platform or just Navis. Bastian, do you want to?
Yeah, it's actually partly possible, I would say. So every loading computer could be integrated into our solution. As long as we receive the loading condition, we can make them available. However, the question is, are we able to read them, and are we able to show you the data inside? Because of course, our own system, we are owning the data structure, and we can tell you each and everything of the loading computer. On a competitive system, we would potentially not be able to read the loading condition and give you all the insights. We are very open for such collaboration. So if any other vendor may be interested to work with us on such integration, this would be technically totally possible.
Oh, okay. I mean, Mike Powell's questions, there's elements that it's not just about sensors. I'm just reading his question properly now. So he's saying you might want to have hull stress monitoring because you've got more knowledge about the weight distribution. So it's linking to the loading computer and motion data. I don't know what motion data. Is that do you know why would you work with motion data, Hannah? Is it?
Yeah, I think what is meant in this case, yeah, actually we are looking into it, and I think also our provider Navis, in regards of the loading computer, has some ideas how to do some motion data, or let's say to integrate the motion data. But we are looking into this, and we are having in our nautical department some ideas what could be added, and but this is, I think, the next step ahead. Not yet in place. That's
some kind of vibration of is that the motion you're talking about, or?
Motion, yeah, how the vessel is moving and all these things, yeah. How the large forces or the stresses from the vessel is then interfering and so on, yeah.
Wow, so Reza is asking about data from Voyage data recorders. I think that's totally separate, is it? Or
Voyage data recorder, actually, I mentioned it in regards of, because there's always some kind of yeah, let's say there's always a bunch of data which is always collected for the Voyage data report, and I just mentioned it in regards of the nautical data. So these data we are actually collecting. So, but what is the request in regards of VDR? Is the data in VDR available to owner ashore? Yeah, let's say it is.
Wow. So Hiro Yoshida is asking about the data frequency. I don't know what high frequency data. You said something about high frequency data, didn't you? 15 minutes or something.
Yeah, let's say if we are talking about high frequency data, or let's say it also depends on what interface you're having. If you're having Modbus or you're having TCP/IP or whatsoever, so there are also different frequencies for the data itself. So, but actually we just started now to have the data every minute. So we have the average taken for this 1 minute, and this will be sent every 50 minutes ashore. So 50 data points per point, let's say, are taken sent ashore.
Oh, that's very good. I'd like to ask you, Hannah, why you chose Navis. I don't know if this is something you're comfortable answering. I mean, there's lots of reasons you gave.
Yeah, actually, I think already the first slide mentioned it, but we were looking for a system which were able to, let's say, fulfill our requirements in regards of data transparency, quality, user interface, and connecting all the data together in one. And actually, we had a trial period with Navis last year for 2 or 3 months. So we were diving quite deep and had a decent on 2-3 vessels, some kind of test phase, and to have a look into it if it really fits our needs. And the approach from Navis actually is something we really like, and we really want to go forward with, because they are having this approach of connecting all data in one single source of truth, to having everything in place. But it's not, yeah, let's say, also taking a lot of work already in pre-sourcing if everything, the data reliability is going and so on. So yeah, it's really nice to work with them, and they are sharing our same opinion, let's say.
Yeah, it's quite a contrast with a lot of the companies we talk to who focus a lot on the algorithm itself. You know, we've got this great algorithm that gives you some right answers, but that also increases the complexity. And I don't know if you necessarily need very complicated.
Yeah, that's a good point. Yeah, if you really need all this kind of complexity, actually, you want to make it more simple, right? To get a better approach and let's say get more done in less hours. So you need to keep it simple in some way.
Yeah, I mean, I think you had one slide when you said what you'd really like be machine learning as well, or something you'd like to add, but that would put the complexity in the other direction. It's a machine learning thing. You saying, I think,
but not for the user. Let's say it's making it for the user. It's making it at the end more easy.
We're aiming to keep the complexity at the software provider and give the user easy to understand results.
let's stay it like it is.
Yeah, we've also have to understand where the software comes from when it starts making recommendations. Otherwise,
I think one thing that's very important, which we may add here, is that whatever complexity we do, we always give the visibility to the user. So if there's any KPI being calculated, you can simply stay with the result, and you can take it as okay as long as it's green. But if you want to dig deeper, you always have the chance to drill down into the calculations, and you can clearly see how the data have been combined with each other and how the result have been achieved. So we are totally open in sharing our complexity. So if the customer is interested, he can drill into, but of course the user interface should always be very intuitive for the customer to use.
Yeah, and Hannah, it sounds like you must have asked a lot of the people in the company what they thought of the software. They must like it as well. Is that something you'd like to share some thoughts on? What you're...
Yeah, absolutely. It was. It's not that we are only using the system within my team. Actually, the software is used by everybody within our company. So it's used by our management, it's used by our operating department, it's used by our QHSE department. So nautical department, superintendents, everybody, because for everybody, there's something which is really beneficial. Also, our controlling uses the system to see, for example, the loop oil consumption and so on. So there, it's an approach that we are having one system actually, which is able to fulfill all our needs. I don't want to switch all the time through different softwares and together all the data together, then at the end again in an Excel sheet. Yeah. So that's also, which is the acceptance of the system is rising a lot.
Wow, and did you roll it out quite quickly, or did it take quite a while to get it embedded in the company?
No, actually, how fast we rolled. After this test phase of 2-3 months, actually, we needed, I think, 2 months to get it set up in this on all vessels, and also within our company. Actually, we also went now this way that we are spraying out to our vessels all some kind of iPads, so that they are also able to have the mobile version of the BTO, and they are seeing absolutely the same what we actually are able to see. So they have the complete login, so they can see everything. So we are having a complete picture where we are able to discuss with. So we're doing also remote sessions with our crews and just talking about the performance or the issues we are facing with.
Well, I missed this VTO, what this means. You've mentioned it a couple of times.
BTO, BlueTracker 1. Actually,
BlueTracker
that
1.
is the system.
The abbreviation of the product, actually.
Okay, I'm sorry. Yeah.
BlueTracker 1. Oh, it sounds great. Okay, well, we've got a couple more questions, I think, for both of you. So Ricardo Trombar is asking if the data is integrated with the plan management system and quality management system. And Taras Favliok is asking, have we got any alerting system by text or email? I don't know which. Maybe Bastian, do you want to give Hannah a break for take one of those?
Yeah, I may. For the first one, for the PMS and QMS systems, I basically just say from the software perspective, it's possible. So the APIs are available, and the integrations is totally possible. And maybe Hannah can add later what the current situation at CPO's use case is, if they do so or not. So on the other question, regards to the notifications, yes, there are email notifications available. We also send out emails in terms of any plausibility issues or something, and any user can copy in his email and can be CC in those notifications. And indeed, this is also an area we are currently working on, little extensions that also in terms of special KPI situations, users can be alerted on several ways. So active notification is of course important topic as well. So you do not need to look into the system each and every time, so you also get notified if something happens. Maybe Hannah, cycling back to the question with the integrations.
Sure. Actually, we haven't integrated PMS or QRS in the BTO, so in the BlueTracker 1 system, but actually we are combining the data in another BI tool at the moment, just to have some better reporting values and options available. But in the BTO at the moment, we are not integrating the data.
Oh, it sounds great. Well, we're coming to the end now. I don't know if you'd like to take a minute and maybe any final comments, and we'll go back to Vida to close things. I don't know, is there, Hannah, anything else you'd like to say just to wrap up? Or it's a very interesting project. I think you've done very well. It seems to be quite exciting.
Yeah, it was a really exciting project, and actually it went pretty well. It was really exhausting also for, I think, both ends. No, but time-wise and what actually we achieved with adding these systems to our company, it's really beneficial. And it was a really good teamwork, and yeah, really appreciate it.
Yeah, great success story. Bastian, do you want to have any final words?
Yeah, thanks a lot, first of all, Carl, for hosting the webinar. It was indeed very interesting and nice exchange, good questions here. What I may just want to add is after the implementation phase, which we had with CPO, which was indeed a great team project here with the customer, we have handed over the updates and the whole procedure of updating the application with further features and stuff to the IT of CPO. So we are just publishing the new versions which are available, and the IT can roll out the software themselves. And this actually happens very, very quickly. So the last update I think has been installed fleet-wide in just only 2 days, because the update patching procedure is also very automated and easy to do. So once the initial setup has been done, updating the software and keeping the latest things into it, it's also pretty smooth. And this is also, I think, a big advantage of the project here, looking into the future and adding additional features.
Wow, that's fantastic. Well done. I shall pass back to Vida for the final words. Thank you.
Thank you. So summing up, we heard about a different take on how to do vessel performance, example of integrating it with a loading computer that is usually not done, but totally possible. It was our last webinar of this month. Digital Ship is having a short Easter break, but we're back on April 14th with a story on reducing cost in bunkering through digital technology and collaboration. Registration is open on webinars.digitalship.com. See you in April. Bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.